Greenland. You probably don't know very much about this land. In your mind, it's just somewhere far up north, freezing cold, sparsely populated, right? But how about a real tour? Not the kind filled with boring trivia about local landmarks or how beautiful the volcanoes and landscapes are. No. Today, you'll hear something that might actually make you want to visit this place. Ready? Let's go. A giant Greenland is moving. Right now, literally, if you ever wanted the slowest ride of your life on a giant piece of land, Greenland is the place. But how is that even possible? The thing is, Greenland isn't a continent, it's an island. The largest one in the world, by the way. And as you probably know, most of it is covered with ice. For centuries, this ice has been melting, and in recent decades, it's been melting even faster. As the ice thins and disappears, the entire island is deforming. And that deformation can affect the whole world. According to scientists, Greenland is shifting northwest at about 0.79 inches per year, while at the same time stretching in some areas and compressing in others. But why is this happening? There are three factors: the movement of tectonic plates, the melting of glaciers, and the most important one is glacial isostatic adjustment. Wait, what? It sounds complicated, but it's actually not. To understand it, lie down on your bed for a moment. Stay there, get up, and then look at the mattress. See the indentation left by your body? See how it slowly rises and smooths out again? That's glacial isostatic adjustment, but on the scale of your bedroom. The same thing happens to Earth's crust when an enormous mass of ice presses down on it. The ground isn't as rigid as it seems. It bends under pressure, and when that weight disappears, it slowly springs back up. The last ice age ended only about 11,700 years ago. Back then, massive slabs of ice more than 2 miles thick covered most of the northern hemisphere. Those glaciers have long melted, but the Earth is still rising, just like your mattress. Why so slowly? Because billions of tons of ice push down on the planet's surface for thousands of years. It takes a long time to recover from that. So, glacial isostatic adjustment is one of the main reasons Greenland is shifting and changing shape. You might not notice it with the naked eye, but from 2002 to 2025, its ice sheet has been losing about 264 gigatons of ice per year. To help you imagine how much that is, here's an example. 1 gigaton equals a billion tons. One blue whale weighs about 200 tons. That means 1 gigaton is the weight of 5 million blue whales. Now multiply those 5 million whales by 264. That's the amount of ice Greenland loses every single year. And of course, melting on such a scale doesn't come without consequences. The melting of Arctic and Greenland ice is reshaping our planet in serious ways. As ice disappears, less sunlight is reflected into space, trapping more heat and driving extreme weather worldwide. Rising sea levels threaten coastal cities and small island nations, while changing weather patterns disrupt agriculture, risking food security. Wildlife such as polar bears and seals lose critical habitats. The melting opens up new routes for ships. It sounds good, but imagine how much oil can be spilled on these routes in the event of shipwrecks. But are there any positive effects of melting glaciers? Actually, yes. New meadows, forests, and fertile areas could appear in places once buried under ice. Sure, this also increases methane emissions into the atmosphere, but let's not focus on the negatives for now. Oh, this is still a tour of Greenland, remember? So, why is a land covered almost entirely by ice and snow called Greenland? Simply put, it was a clever marketing trick by the Vikings. Greenland was founded by Eric the Red around year 982. He was a strong, hot-tempered Viking who had been exiled from his home in Iceland. He was the first to build a settlement on the island, and then began inviting other Europeans to join him. And to attract them, Eric the Red described the island as green and fertile, and even named it Greenland. In a way, he wasn't entirely lying. About 2.5 million years ago, the island really was green, but the marketing campaign didn't work as well as Eric probably hoped. Even today, Greenland remains one of the least populated places on Earth, with about 57,000 residents. Yes, it attracts tourists, but not even close to the number visiting Rome or Barcelona. So what's the coolest thing about this island? Transportation. Inside the towns, you'll find regular roads, but there are no highways connecting one town to another. And you won't find any railways either. In the capital, Nuuk, you can drive your car around, but if you want to travel to another town, like Kurortok, you need a snowmobile or a dog sled. There's always the option of taking a helicopter, but that can get expensive. The most popular mode of transportation here, though, is the boat. Isn't that amazing? While most of us are used to road trips and train rides, the people of Greenland regularly glide through icy waters surrounded by towering icebergs. If you don't like the cold, you can visit this place during the summer. In the southern part of the island, temperatures can reach 48 degrees Fahrenheit and even higher, but be prepared for sleep problems. From May 25th to July 25th, the sun doesn't set. Day and night, the sky stays bright, and that can definitely cause insomnia. On the other hand, you'll get to witness an incredible natural phenomenon, the midnight sun. And from September to April, you can see breathtaking northern lights. But if you're into mysteries and historical puzzles, you might want to explore one of the biggest enigmas tied to Greenland. It's the disappearance of the Vikings. As you know, Eric the Red founded a Viking settlement here. Around the year 985, Norse people sailed from Scandinavia and reached the southern coast of Greenland, where indigenous people, ancestors of modern Inuits, had already been living. Those locals were skilled hunters and fishers and were doing perfectly well. It's unclear whether they had huge battles with the newcomers or not, but there were local fights between them and the Vikings. So they lived here for about 500 years. They built houses, enjoyed views, made families, and developed a functioning community. And then, they abandoned the settlements. The only thing left behind were the ruins of their settlements. So, what happened to them? The popular explanation was Vikings failed to adapt to the climate. When they first arrived, the weather was warmer, but then temperatures began to drop dramatically. Vikings were fighters and traders by nature. They raided, they traveled, they bartered, but none of that mattered much in Greenland. Maybe they simply couldn't change their lifestyle and switched to fishing and hunting. However, this version has been rejected by many experts because archaeologists found remains of large Viking farms. Research shows that at least several thousand people lived here. The last written records about them date to letters from 1424. Everything seemed to be going just fine. It seems the Vikings tended animals and learned to handle the cold, but then something happened. In the 1700s, Protestant missionaries sailed from Norway to Greenland, but upon arriving, they found only Inuit people, not a single Viking. Recent studies propose a much more realistic theory of what happened. The disappearance of the Vikings coincides with the beginning of the Little Ice Age, a period during which temperatures dropped sharply in many parts of the world. This cooling caused sea levels around Greenland to rise. Wait, how can cooling cause sea levels to rise? Doesn't that usually happen during warming? Remember glacial isostatic adjustment? As the ice mass on Greenland grew heavier, it pressed the land downward. The coastline sank. The Vikings likely weren't prepared for the sudden cold and the flooding of their settlements. And so, they left. But of course, this is still just a hypothesis. What do you think happened? It's one of America's strangest contradictions. The Northeast, the cradle of cities, commerce, and crowds, hides a vast, empty wilderness at its northern edge. Millions live packed together to the south, yet up here, there's space for everyone, and almost no one takes it. How did this happen? How did the heart of America's most crowded region end up with one of its loneliest frontiers? The northeastern United States is home to more than 50 million people. It's one of the busiest and most densely packed regions in all of America. But almost 90% of those people live in the southern half of it. If you go north, past big cities and highways, everything will change. The noise will fade and the lights will thin out. You'll find yourself in a different world. A quiet land of forests, lakes, and mountains, stretching across northern New York, Vermont, New Hampshire, and Maine. This is America's empty Northeast. And the mystery is simple. Why is this part of one of the most crowded regions in the country so empty? First of all, let's take a look at New England itself. Massachusetts and Rhode Island are bursting at the seams, while Maine, Vermont, and New Hampshire feel wide open. Connecticut sits in the middle, literally and figuratively. Massachusetts is basically the crowd magnet. Most people live around Boston and the cities nearby, Cambridge, Worcester, Springfield, where everything's close, busy, and built up. Rhode Island may be tiny, but it's got a big city density. Connecticut sits right between Boston and New York, and it shows. It has a busy coastline and quieter inland towns. It's not too crowded and not too empty. The middle ground. Once you cross into New Hampshire, things slow down. There's Manchester and Nashua, but most of the state is forests, lakes, and open land. Then there's Vermont, easily the least crowded region of the bunch. The Green Mountains slice through the middle, and most people live in small towns or villages. And Maine is huge and mostly empty. Most people stick to the southern coast. If you head north, you'll hit endless forests, lakes, and long, quiet roads. It's beautiful, but it feels like the edge of the map. Today, the northern half of the Northeast, northern New York, Vermont, New Hampshire, and Maine, holds only about 4.9 million people. That's roughly the same as the population of the Boston metro area alone. To put that in perspective, if you take southern New York and southern New England, about the same land area, you get 10 times as many people living there. So, why the gap? It all comes back to geography, history, and economics, and how they've always worked together to keep the North empty. Let's start with the land itself. The thing is, the farther north you go, the rougher the land gets. Southern New England and downstate New York are full of rolling hills, wide valleys, and coastal plains. But then come the mountains. They're old, crumbling, and wild. In northern New York, you'll see the Adirondacks. To their east, the Green Mountains run up the middle of Vermont, stretching into Quebec. Keep going and you hit the White Mountains of New Hampshire. They're home to Mount Washington, famous for some of the most severe weather on Earth. And beyond that, the western Maine Mountains roll on toward Canada. Those aren't gentle hills, they're real barriers, and they owe their shape to one of the most powerful forces in Earth's history: ice. During the last ice age, huge glaciers covered this land. When they finally retreated, they carved out deep valleys and left behind thin, rocky soil. Later, the basins filled with water, creating thousands of lakes and ponds. It's a beautiful but difficult land to live on. Farming never stood a chance here the way it did farther south, where the soil is way richer. So the mountains stayed wild, covered in dense forests that even today stretch for miles. Northern Maine and the Adirondacks together make up one of the largest continuous forests east of the Mississippi. For centuries, people have come here to cut timber, fish, or hunt, but never in great numbers. And then there's the weather. Up here, winters are long, dark, and cold. Snow piles up early and doesn't leave easily. Summers are short, and the growing season is barely long enough to farm. It's not exactly a place that says, "Come start a new life." But of course, some people did. And here's where history comes into play. Long before Europeans arrived, this land was home to indigenous nations. The Abenaki, living across Vermont, New Hampshire, and Maine, had complex trade routes, connecting their communities all the way from modern Quebec to Massachusetts. Farther west, the powerful Iroquois Confederacy extended its influence toward the Adirondacks, controlling vast hunting grounds and trade routes. Then came the Europeans. In the 1600s, French explorers and fur traders pushed south from Quebec. They set up outposts along rivers and lakes that linked the region to Canada. They saw opportunity. Furs, fish, timber, but not farmland. The dense forests and harsh winters kept settlements small and scattered. The English, expanding north from the Massachusetts Bay Colony, took to the coast. They settled in southern Maine and New Hampshire, but going inland was another story. Between the cold, the forests, and the resistance from native nations, their progress was slow and dangerous. For more than a century, the interior of the northern Northeast stayed wild. Later, around the 1760s, the British took control of the region. Land speculators moved in, especially in Vermont, which both New York and New Hampshire claimed as their own. The overlapping claims led to chaos, and eventually, Vermont declared itself an independent republic in 1777. For 14 years, it existed on its own until it joined the United States in 1791 as the 14th state. New Hampshire pushed inland from the coast, building towns in the valleys between its granite mountains. Maine, meanwhile, spent centuries as parts of Massachusetts. Its economy ran on timber and shipbuilding. Trees turned into masts and planks for the growing British and later American navies. And in northern New York, the Adirondacks remained a wild frontier long after the rest of the state filled up. The land was too rugged and the winters too fierce. Logging, mining, and later tourism would bring people north, but never in huge numbers. By the mid-1800s, the southern parts of New England were booming. Cities were growing, factories were humming, and immigrants were arriving in large numbers. But the northern regions stayed quiet. So as we now know, the mountains are the first big barrier. They make everything harder: travel, building, farming, and surviving winter. The soil is thin, rocky, and poor. And what's underneath isn't much better. The region doesn't have rich mineral deposits or coal seams like the Appalachians farther south. Without valuable resources to mine or easy land to farm, there wasn't much reason for settlers to stay. That was one of the reasons why the economy never took off. The empty Northeast never became a center of industry. Southern New England had rivers that powered early factories, ports connected it to global trade, and the cities attracted millions of immigrants. Northern New England and northern New York had none of that. They had lumber, granite, and paper mills, all useful, but those industries didn't create huge cities. Even today, the economy up there relies on the same resources, along with tourism. People come to hike, ski, fish, and escape city life, but most don't stay year-round. Towns fill up in summer and fall, then empty out when the snow starts falling. A few small cities, Portland, Burlington, Manchester, thrive, but there's no Boston or New York up here. You won't find massive universities, corporate headquarters, or international airports to pull in young people and families. In fact, some states have gone so far as to pay people to move there. Maine and Vermont have both launched programs offering money to remote workers who relocate. That's a pretty desperate attempt to reverse decades of population decline. Today, this empty Northeast holds just about 1% of America's population. It's a land of deep woods, icy lakes, and quiet towns. The wilderness never really left this region, but that stillness is also what makes this place so special. The rest of the Northeast is filled with constant noise and motion. Meanwhile, the North is a reminder of what the region once was: wild, cold, and untamed. That's how the heart of America's most crowded region remains one of its last true frontiers.
Now, this tiny town on a U.S. map used to exist only on paper, literally. Agloe was never built, never had a mayor, and yet, for a short while, it was officially on the map. Back in the 1930s, two map makers from American's General Drafting Company were hired to make a map of New York State. But they wanted to protect their work from copycats. So they created a ghost town and named it after themselves, Otto G. Lindbergh and Ernest Alpers. Take their initials, mix them up a bit, and you get Agloe. Or is it Agloe? Well, no one's quite sure, since it never existed anyways. You see, creating fake towns used to be a thing, because copying maps was also a thing. In the past, map making was serious business, and protecting your work wasn't easy. So cartographers got clever. They started adding tiny traps, fake streets, made-up lakes, even whole towns to spot copycats. These sneaky details were called trap streets or paper towns. If someone copied your map, they'd copy your invention too. It was a quiet way of saying, "Busted," and then taking them straight to court. Then the funniest thing happened. A few years later, another company published a map with Aglo on it. When confronted, they said, "It's not fake. There's a general store called the Aglo General Store right there." Turns out, someone had seen the town's name on a map and decided to open a shop under it. Today, the store is gone, and Aglo is back to being just a lonely road intersection in the Catskills. Now sometimes fake lands appear on USA maps not on purpose, but because of simple cartography mistakes. Take Isle Filippo, for example. This mysterious island with a fancy name was once proudly shown on maps of Lake Superior, even though it never existed. Back in the 18th century, French travelers were busy exploring the Great Lakes when they saw, or thought they saw, 4 islands out there. Let's just say their methods weren't always precise. But a French cartographer named Jacques-Nicolas Belin didn't know that. He trusted their travel notes and drew Isle Philippe on a map he made in 1744. The problem is that other map makers trusted Belin's work and copied the island onto their maps too. Before long, Island Filippo was as real as any place could be, on paper at least. It stayed on official maps, confusing travelers all the way into the 1820s. That's when explorers finally checked and realized, wait, there's nothing here but open water. Today, historians think the whole thing was a mix-up. The explorers probably confused it with Isle Royale, a real island that's part of Michigan. They were described as 2 islands about the same size, but there was only one all along. Next stop, Nothing. You heard that right, Nothing is the real name of a tiny ghost town in Arizona. If you ever drive down Route 93 between Wickiup and Wickenburg, keep an eye on the towers along the way. On one of them, there used to be a wooden sign painted in red letters that simply said nothing. Hopefully it's still there. This spot marks what's left of a once hopeful settlement in the middle of the blazing desert. Back in 1977, a man named Richard Buddy Kenworthy decided to found his own town. He built nothing out of almost nothing. The place had a gas station and a tiny convenience store, but that was it. Then he added a big yellow sign that proudly declared, "The Town of Nothing, Arizona. Population 4." And yep, that was its peak, only 4 inhabitants. I know your family dinner table might have seen bigger crowds. But anyway, in May of 2005, Kenworthy packed up and left, and Nothing was officially abandoned. 3 years later, its famous gas station began to crumble. But some fans, I guess we can call them that, decided to bring Nothing back to life. There was even a small pizza place running there for a while, but it didn't last long. By 2011, Nothing was, well, nothing again. And today, it's one of the most famous abandoned towns in the USA. Now speaking of abandoned towns, some were lost to time, others to something far more dangerous, like Centralia, Pennsylvania. From a distance, everything looks fine, but take a closer look, and you'll notice something strange. Roads cracked open, smoke rising from the ground, and no people in sight. That's because Centralia isn't just abandoned. It's been on fire for more than 60 years. It all started back in 1962. Although there were many theories about how the fire began, the results are well known. The flames spread into the labyrinth of coal mining tunnels running beneath the town, causing devastation as they went. Fissures opened in the ground, sending plumes of smoke and toxic gases into the air, and the fire never stopped. That's right. At first, no one thought much of it, especially because everything was happening underground, out of sight. But soon, smoke began seeping up through the soil. Then, in 1981, a huge sinkhole suddenly opened under the feet of a 12-year-old boy. Thankfully, he grabbed onto a tree root and survived. But that was all the proof locals needed that the fire wasn't going away. Experts warned that the underground blaze could keep burning for more than 250 years. and that's why most of Centralia's 1,000 residents decided it was time to pack up and leave. Today, fewer than 10 people still live there, refusing to move. The rest is nearly a ghost town, with empty streets and crumbling foundations. They don't even have a zip code anymore. Beneath it all, the coal is still burning quietly, making Centralia one of the eeriest forgotten towns in America. And now you might be wondering, how many more of these towns are out there in the U.S.? Well, a lot. Just in Texas alone, there are an estimated 511 ghost towns that are now completely deserted. Then there's Nevada, believed to be home to over 600 phantom towns, many of them left behind after the gold and silver rushes of the 18 and 1900s. People moved there to work in the mines, and when the mines shut down, they left. But abandoned towns and mapping errors aren't just a U.S. thing. Even in the age of satellites and Google Earth, fake cities still manage to sneak onto maps all over the world. One of the most famous modern examples is a place called Argleton. Back in 2008, a guy named Mike Nolan was checking out Google Maps, looking around the area where he grew up, in West Lancashire, England. Then he spotted a city called Argleton, but something felt off. He remembered that spot being just a farmer's field near the village hall. Maybe a footpath crossed it, but that was about it. There was definitely no real city out there. And he was right. It was a total mistake. Nobody knows exactly how it got there, but it did. Don't bother looking for it, though. Argleton was officially removed from Google Maps by May 2010. And even if you look for its old coordinates today, you'd only see an empty, muddy field. Alright, so Argleton might have been fake, but it sure had a lot of fans. When people first discovered it online, they went a little wild. And then came all the jokes. People were actually selling souvenirs that said, "I visited Argleton and all I got was this t-shirt." Some local restaurants even offered Argleton pie, and the ingredients were, well, nothing. Believe it or not, even today you can still find merch online celebrating the world's most famous Google Phantom Town. Well, that's the end of our tour of the strangest ghost towns on the maps of the USA, and even beyond. So, tell me, have you ever been to an abandoned city before? Have you ever discovered hidden places on the map that shouldn't even exist? Well, share your story in the comments below.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever Anita has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They published the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. Anita is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Wiesel explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas like maybe it's some new kind of physics or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
The floor starts quaking like it's alive. Books, mugs, and lamps leap off shelves. Your feet slide, your body sways, and you can barely stay upright. It stops for a second, but then it shakes again and again. More than 1,000 times just in one day. This is not how you imagined your trip to Santorini, but it's the new reality. The Santorini seismic swarm started in January 2025. In less than 1 month, there were, get ready for it, more than 20,000 reported earthquakes. For comparison, most cities on Earth go through one small, barely noticeable quake in a year. It all started with small jolts that residents could feel, but tourists might have mistaken for large trucks driving nearby. But by February, things got serious. A magnitude 5.3 quake struck. It's a moderate-strength earthquake, but it was strong enough to rattle homes, break windows and dishes, and terrify the island's population. The Greek authorities declared a state of emergency for Santorini and Amorgos. Thousands of people had to leave their homes. Schools closed, and hotels temporarily evacuated their guests. Santorini is famous for its volcano, the one that blew up in a massive eruption around 1600 BCE and inspired the legend of Atlantis. It's still considered to be active, although there have been no significant eruptions since the 1950s. So it would be logical to blame this monster for all the drama. But nope, these tremors weren't volcanic. Experts said what was happening near Santorini looked like a seismic swarm. It's a series of smaller quakes all happening in the same area. They are happening along faults, which are cracks in the Earth's crust that can suddenly shift when the tension gets too high. Think of the ground like a giant, stressed-out Rubik's Cube. At some point, it twists and snaps somewhere. Near volcanic areas like Santorini, fluids moving underground can sneak into these cracks and make them easier to break. Plus, there's the natural stress from tectonic movements. It's like adding oil to a squeaky, overworked hinge. Suddenly, everything slips. Nobody knows exactly what's coming next. Tracking thousands of tremors isn't easy. Many of them are too small for traditional seismic sensors to pick up. But this time, scientists have their new best friend to help out. I'm talking about artificial intelligence. Thanks to machine learning, researchers can detect patterns in tiny vibrations that humans might miss. This technology has helped a lot to understand the swarm. It lets scientists map which parts of the crust are most active and even predict possible future activity. The AI analysis suggests the quakes aren't random. They seem to be clustered along a fault line near the underwater Colombo volcano. This area has a long history of seismic activity. Even though Colombo hasn't erupted recently, the magma beneath it might be subtly shifting the crust. and it adds tension to the tectonic plates above. It's like a simmering pot. Nothing boils over yet, but the heat is definitely building. The swarm has subsided after a couple of months of constant shaking, but it doesn't mean it's over for good. Even after a lull, another swarm could strike, or a larger quake could happen along the same fault lines. That's why scientists are now studying the data collected from the swarm. If you're thousands of miles away from Santorini and don't have plans to visit, it doesn't mean you're 100% safe from a similar scenario. Seismic swarms like the Greek one happened in the Caribbean, Iceland, and Italy. One of the best documented swarms in history happened in Japan, in a suburb northwest of Tokyo. It was all going on in a town sitting on a seismological observatory, like a secret underground lab for tracking earthquakes. The swarm kicked off in August 1965 with just 3 earthquakes that were so weak nobody could feel them. But things escalated fast, and 3 months later, 100 quakes a day were strong enough for people to feel. On one day, the observatory recorded almost 7,000 quakes. Out of those, 585 were strong enough to actually shake the ground, meaning you could feel a quake roughly every 2.5 minutes. Scientists figured out that the swarm was caused by fluids moving underground, kind of like the Earth's crust, stretching and bubbling. Studying seismic swarms helps scientists predict earthquakes better, understand how Earth's crust moves, and even prepare for future natural disasters globally. For instance, if they can link the patterns of tremors to magma movement or tectonic shifts, they can apply similar models to volcanoes and fault lines in Hawaii, Iceland, or the Pacific Northwest. Santorini is like a living lab where they combine modern tech with traditional knowledge. AI, seismographs, and satellite imaging add to centuries of human observation. The locals who have lived through quakes for generations contribute insights about small tremors, changes in groundwater, and unusual animal behavior. All this helps scientists refine their models. Santorini's swarm has surely grabbed the attention of the whole world, but it's not the only place on Earth with some intense seismic activity. But what makes Santorini unique is its combination of historical volcanoes, underwater fault lines, and the fact that it's a real tourist magnet. The island is not so large, and the effects of even moderate tremors feel stronger and more dramatic than in other regions. In other places, though, even more serious earthquakes, tsunamis, and volcanic activity are regular news, and the people have learned to live with them. Japan is one of the regions on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. There are around 1,500 of these earthquakes each year that are noticeable. Because of this, the people in Japan have learned to live with earthquakes. There's even a law that sets a rule that buildings in the country should be able to handle earthquakes up to a magnitude of 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is not to collapse, but to save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. They even construct some buildings on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot and move up to 5 feet, but it won't collapse. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happened every 500 years on average, but for a long time now, Cascadia has been quiet, and the scientists are getting worried. They think this might be because the area is locked, so the tectonic plates are stuck together and building up a lot of pressure. At some point, a part of the seafloor could suddenly break and move forward by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. This could make the hillside slide and crumble and take down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse. Scientists are hoping that thanks to advanced AI tech and local communities, they'll be able to better predict earthquakes like this and the one in Santorini. This could save thousands of lives. And for now, we must not forget that the Earth doesn't take vacations when it comes to seismic activity, even in places where you go on vacation. This whole part of our planet has disappeared. It used to be a tectonic plate, but something that big doesn't just vanish without a trace. And the clues that led to its discovery started in this mysterious gap between South China and the island called Borneo. For a long time, people thought the sea between these two places sat on a tectonic plate called Izanagi, which no longer exists. But wait, how does a tectonic plate just vanish like that? Alright, tectonic plates are like pieces of a puzzle all connected together. But instead of sitting on a table, they're floating on this semi-fluid layer. So they're always shifting and bumping into each other. And there's something else. Some pieces of this puzzle are heavier than others. And what happens is that eventually, a heavier piece slips under a lighter one. Something similar happens with tectonic plates, but it's less about weight and more about density. When the edge of one plate sinks below another and gets pushed down into the mantle, that process is called subduction. But it's not just the edge that can sink. Entire massive plates from the past have completely vanished into the Earth's mantle. That's exactly what happened to the Izanagi plate. About 130 million years ago, it started sliding under the Okhotsk plate, getting swallowed little by little. By around 55 million years ago, it was completely subducted and replaced by the Pacific plate. And for years, specialists thought that the ocean between China and Borneo was sitting on that plate before it disappeared. Cool, but the experts got it wrong. Turns out the ocean between these lands wasn't sitting on the Izanagi plate after all. Instead, it fits into this weird, unexplained gap, as if a piece of the puzzle was missing. Recently, researchers at Utrecht University finally discovered that this gap was actually a ghost tectonic plate that no one knew about, the Pontus plate. It got its name because back when it existed, it sat beneath the ancient Pontus Ocean. But if it vanished so long ago, how did experts find it, right? Luckily, tectonic plates sometimes leave traces before they completely disappear. But instead of investigating footprints or fingerprints, it's more about looking for rocks. Yeah, stones from a lost plate can get incorporated into mountain ranges and show us where those ancient earth layers were. That's because rocks have a special power to record Earth's magnetic field. You know, that invisible shield that protects our planet from space threats, like solar wind and cosmic rays? So, as rocks cool and solidify, the magnetic materials in them, like magnetite or hematite, line up with Earth's magnetic field at the time and get locked in. They can freeze a record of the magnetic field direction and strength. And since it changes depending on latitude, basically whether it's further north or south on the planet, it allows the rocks to kind of take a snapshot of their ancient position relative to the equator. Knowing this, researchers traveled to Borneo to collect and study the rocks over there. And they discovered something odd. These stones were originally from a much farther north region. Their ancient coordinates didn't match the latitude they expected for Izanagi. In fact, they didn't match any of the tectonic plates we knew about up until then. So they quickly realized two things. One, they had just discovered an eerie gap. Two, there must be a hidden ghost tectonic plate that used to be in that spot. To unravel the mystery, scientists used computer models to study the region's geology over the last 160 million years. Thanks to this technology, they were able to piece together the entire Pontus Plate in all its glory. The next step was to figure out the key features of this part of our planet that had been submerged, like its age. You see, the rock samples collected in Borneo date back 135 million years, back when dinosaurs ruled the Earth. With this information, scientists realized that the Pontus Plate was formed at least 160 million years ago, but it's probably even older than that. Although it is hard to pin down exactly when it was formed, one thing we can say for sure: it was huge. The Pontus Plate was about 1/4 the size of the Pacific Ocean. Unfortunately, by around 20 million years ago, it said bye-bye to the planet, sinking and being completely pushed under the Australian plate to the south and China to the north. At this point, you might be wondering if a couple of rocks and a computer reconstruction are enough to prove that the Pontus Plate really existed. Well, yeah, they are. But other clues have also been found in Palawan, an island in the western Philippines and in the South China Sea. The truth is that the scientific community has suspected the existence of Pontus for over 10 years. At that time, researchers were really focused on the area around the Philippines. This region is like a playground for geologists, since it sits at the crossroads of several tectonic plate systems. So, scientists decided to reconstruct the movements of the Earth's crust between Japan and New Zealand. And because of that, the study suggested there had to be a subduction zone running through there, separating the known Pacific plates in the east from the hypothetical Pontus Plate in the west. These previous predictions were possible because tectonic plates are really bad at playing hide and seek. Like we said before they get submerged, they leave clues behind. And it's not just rocks. They can also change the Earth's mantle, which leads to the formation of volcanoes, earthquakes, and deep ocean trenches, for example. But the subduction process can also mess with the composition and temperature of the mantle, making some areas hotter or cooler. These are considered anomalies. It is possible to detect these anomalies using seismographs, which are instruments that pick up earthquake signals and record the ground's motion. When earthquakes happen, they send out ripples or waves through the Earth. These waves travel through the Earth's layers, but if they hit something unusual like an ancient piece of a tectonic plate hidden in the mantle, the waves get disrupted. It's like hitting a bump on a smooth road. It messes with the ride. Using regular seismometers to look for anomalies is fine, and it can totally help us find clues about the Earth's past. But if scientists want to use this method to get pictures of what's really going on beneath the surface, it gets a lot trickier. Not only do the images come out in low resolution, but the process also becomes insanely expensive. So recently, experts just uncovered a cutting-edge technique that could completely change the way we look at the Earth's depths. Kind of like an ultrasound, scientists can now actually see what's happening miles beneath our feet. More specifically, in a region between the Earth's brittle crust and the mantle underneath, known as the MOHO. This new method is called Distributed Acoustic Sensing, or DAS. It uses fiber optic cables, the same ones that give us high-speed internet, as earthquake sensors. Here's how it works. Laser beams are sent through the cables, and when the ground moves, whether from an earthquake, traffic, or other vibrations, the shaking changes how the laser light bounces around inside the cables. The cool part is that we can now measure these changes all along the length of the cable, so the cable ends up acting like hundreds of tiny earthquake detectors spread out over a huge area. This new tech can tell us things like whether major faults go all the way into the mantle, how ancient and modern processes have shaped the continents, and how strong the deep crust is in certain areas. In other words, DAS could be a game-changing instrument to help us uncover new clues about hidden and ancient tectonic plates. I guess it's no surprise that it's not that easy to just hop on a plane and literally fly to the South Pole, aka Antarctica. Sure, there are airports down there, but they're not really set up for commercial flights. So most people go to Punta Arenas International Airport in southern Patagonia, Chile, and then take a boat if they want to see some penguins. But not only is it hard to fly there, it's even harder to fly over there. When you're cruising at 30,000 feet, you probably don't think much about what's happening below. But it's pretty unusual for flights to go directly over the South Pole, and planes flying across Antarctica are quite rare too. Technically, it is possible. I've already mentioned that there are airports there. But even so, the infrastructure down there is still super limited. There simply aren't enough airports or refueling stations to support regular commercial flights, making it tricky to operate in such a remote area. Plus, there are only a handful of specialized cargo and transport flights that go in and out, and they exist to cater to those few folks who actually live in Antarctica. Then there's the weather that drives up the costs. The simplest example is that the pilots there need special training, which costs money, which is all because of the weather. Another hurdle is something called ETOPS. These rules dictate how far twin-engine planes can fly from an airport. Since there are so few airports in Antarctica, it's tough for pilots to stick to these regulations. Historically, ETOPS made it next to impossible to fly close to or over the South Pole, while flights over land have plenty of airports to choose from. Antarctica is a whole different ballgame. These days, some aircraft can fly up to 330 minutes or, in rare cases, even 370 minutes from an airport. But even with those extended limits, certain parts of the airspace above Antarctica are still off-limits. Still, in the grand scheme of things, that might not be a huge deal. The most curious of you must have Googled that already and found out that there really are Antarctic airways. Please do not judge fast, and don't say I wasn't right saying how hard it was to fly to the South Pole. Let me break it down for you. Antarctic Airways advertise as the world's most exclusive transcontinental flight, but don't think you can just waltz in and book a ticket anytime. For starters, Antarctic Airways mostly operates flights to King George Island from December to March, so it's not all year round. But there are many more reasons why these flights are unique. If you dig into their website, you'll find you've got two choices: a full day in Antarctica or an overnight adventure. Prices kick off at $5,500 for a day trip and go up to $6,500 for an overnight stay. And if you're considering a private charter, get ready to shell out a pretty penny. It's rumored to start at around $125,000. Sure, that's a steep price compared to your average cruise ship crossing the Drake Passage, but here's the thing. It's about 20 times faster. A cruise ship takes 2 days from Chile, while Antarctic Airways gets you there in just 2 hours. Air travel to Antarctica is pretty limited, likely due to the high costs, limited seating, and the logistical challenges that come with flying to such a remote location. Plus, flights can often be delayed because of bad weather. Most travelers opt for a quick day trip or an overnight stay on King George Island, usually aboard smaller Beechcraft King Air 300 aircraft. The experience typically includes a stroll to a research station and a boat ride to see nearby penguin colonies, but that's just scratching the surface of what Antarctica has to offer. But once you're aboard Antarctic Airways, you'll see it's just like a regular flight on a smaller plane. You'll be served meals that have received some pretty good reviews. There are even photos floating around online showcasing the food, and honestly, it looks awesome. Those who've experienced it say it's luxurious yet unpretentious. You'll get a mix of meats and cheeses, plus treats like tiramisu, salmon salad, a single after-eight chocolate, and a selection of quality street candies. Today, everything may seem cool and safe, but back in the day, there were some pretty tragic events. On November 28, 1979, Air New Zealand Flight 901 tragically collided with Mount Erebus on Ross Island, Antarctica. Unfortunately, all 237 passengers and 20 crew members aboard lost their lives that day. Since 1977, Air New Zealand had been running regular sightseeing flights over Antarctica. This particular flight took off from Auckland Airport in the morning, with plans to spend several hours exploring the stunning Antarctic landscape before heading back to Auckland via Christchurch that evening. Initially, the inquiry into the incident pointed the finger at pilot error. However, growing public concern led to the establishment of a Royal Commission of Inquiry for a deeper investigation. The commission found that the crash had been primarily due to a change in the flight path coordinates made the night before, which the flight crew hadn't been informed about. As a result, instead of being guided by the computer down McMurdo Sound, as they were led to believe, the aircraft was mistakenly redirected toward Mount Erebus. In a way, this flight looks like modern one-day Antarctic tours. Flight 901 was marketed as a unique sightseeing adventure, complete with a knowledgeable Antarctic guide who highlighted various scenic spots and landmarks through the plane's public address system, while passengers enjoyed a low-altitude tour of McMurdo Sound. These flights operated as day trips, taking off from New Zealand and returning on the same day. The plane departed from Auckland International Airport at 8 a.m., aiming to land in Antarctica, with a scheduled return to Christchurch International Airport by 7 p.m. The total journey covered about 5,360 miles, including a 45-minute stop in Christchurch for refueling and crew changes before completing the final 464 miles back to Auckland, arriving at 9 p.m. Back in November 1979, tickets for these flights were priced at $359 per person, which is over $2,150 in today's money. Anyway, this tragedy isn't the reason why planes don't fly over the South Pole. The real culprits are weather, ETOPS regulations, and of course, penguins. Yep, those cool, friendly little creatures, friendly at least according to researchers. With no natural predators on land, all of them are in the water. They're not really afraid of people and actually seem to enjoy our company. The South Pole is completely uninhabited and packed with penguins, making it pretty tricky to build anything down there. By the way, the North Pole actually allows planes to fly over it. Not too long ago, there were direct flights from Copenhagen to both LA and Tokyo, operated by SAS, and they cruised right over the North Pole. Other airlines joined in too. For example, Emirates ran a flight from Dubai to LA that took the same route. The difference in air traffic between the two poles mainly comes down to where people live and how much land there is. Roughly 88 to 90% of the world's population hangs out in the Northern Hemisphere, while only about 10 to 12% call the Southern Hemisphere home. Most folks in the South are clustered around the equator in places like Indonesia, Central Africa, and Brazil. When it comes to flights heading to the South Pole, options are pretty limited. You mainly have routes connecting New Zealand and Australia, parts of southern South America, and a few spots in southern Africa, especially South Africa. There aren't really any direct flights over the South Pole, though some flights can get close to Antarctica. One possible route could connect Auckland, New Zealand to Cape Town, South Africa, but there aren't any scheduled flights for that right now. The few flights that came close to Antarctica are operated by Qantas and LATAM Airlines, linking Australia with Buenos Aires and Santiago de Chile. In 2021, Qantas took a long detour over parts of Antarctica on a flight from Buenos Aires to Darwin, and in July 2023, they adjusted a route closer to the continent to dodge some fierce headwinds on a trip from Santiago to Sydney. This invisible line divides the world into two parts, and most animals, fish, and birds, for some reason, can't cross it. The line is called the Wallace Line, and it runs between Australia and Asia. It has its name after Alfred Russel Wallace, a British scientist and explorer who discovered it in 1859. He traveled to Asia to explore a group of islands called the Malay Archipelago. As Wallace walked through the jungles, climbed hills, and sailed on boats, he noticed something like an invisible wall. On its west side, in places like Borneo and Sumatra, he saw animals you might find in Asia. There were big rhinos munching on leaves and monkeys swinging from tree to tree. The forests were full of life, with all kinds of animals you'd expect to see in a jungle. But in places like Sulawesi and Lombok, just across the imaginary line he came up with, Wallace found animals more like the ones in Australia and colorful birds like cockatoos. The behaviors of animals differ on different sides of the Wallace line. Some creatures are great at traveling across tough barriers like water, but others are not. For example, bats can fly across open water, but they sometimes cross the Wallace line. On the other hand, big animals that live on land like elephants usually stay on just one side of the line. Some birds are shy and like to stay hidden in thick bushes and trees to avoid predators. They wouldn't feel safe flying over wide stretches of water with no place to hide. Plants don't stick to the Wallace line as strictly as animals do, because they spread in their own unique ways, like with seeds carried by the wind, water, or animals. One plant genus, the eucalyptus, mostly stays on the Australian side, but one eucalyptus tree has made its way to the Philippines on the Asian side. Underwater, the Wallace line doesn't matter as much. The area between the Wallace line and Australia is called the Coral Triangle, and it's bursting with life. Now, after more than 150 years, scientists think they finally have an explanation of the Wallace line mystery. They believe it all started about 35 million years ago, when Australia broke away from Antarctica and slowly moved up to crash into Asia. When this happened, the crash created a chain of islands called the Malay Archipelago between Asia and Australia. This caused extreme changes in the weather, which made the area very different and affected which animals could live there. Researchers used a computer model that looked at how more than 20,000 species of animals from both sides of the Wallace line would have behaved millions of years ago. When Australia started to drift away from Antarctica, it opened up a huge new era of deep ocean around Antarctica. This is where the biggest ocean current on Earth, called the Antarctic Circumpolar Current, began to flow. This swirling current made the planet's climate much cooler and completely changed how animals could live in different places. But not all animals were affected in the same way. Indonesia stayed warm and rainy, which was perfect for animals from Asia. These creatures could hop from island to island like stepping stones and make their way toward Australia. But animals from Australia had a harder time. Over millions of years, they had gotten used to living in cooler, drier places, so the tropical islands didn't suit them as well. Scientists believe if we can see how animals adapted to big changes in weather patterns millions of years ago, we might be able to predict how today's animals will cope with a similar situation. Other scientists after Wallace also tried to describe and explain the invisible natural border between Asia and Australia, and came up with their lines. The Weber line, for example, is in a slightly different location than the Wallace line, between the Oriental and the Australasian faunal regions within Wallacea. It's a group of mainly Indonesian islands that are separated by deep water straits from the Asian and Australian continental shelves. They were never connected to the big continents by land, so animals that could swim, fly, or float across the water made it to these islands. That's why the creatures living there are so unique and come from both Asia and Australia. Weber's line is where the balance tips. If you go one way, most of the animals are from Asia. If you go the other way, most of the animals are from Australia. Another important migration event in the history of our planet happened in the Americas. Around 30 million years ago, South America became a separate landmass as tectonic plates moved and pulled it away from Antarctica and Africa. Once it was on its own, the animals living there started to evolve in unique ways and turned into creatures you couldn't find anywhere else in the world. There were animals we still see today, like opossums, giant rodents like capybaras and chinchillas, armadillos, anteaters, and sloths. Some of the animals from those times are now extinct.
there were giant ground sloths, bigger than cars, roaming around. There were glyptodonts, which were like giant armadillos with super tough, bony shells. There were also huge, scary birds that couldn't fly but could chase down their prey. Up in North America, animals could still travel to other parts of the world through the Bering Strait. So North America was full of different animals like deer, bison, horses, camels, and even mammoths and mastodons. They all lived alongside predators like big cats, wolves, and bears. About 3 million years ago, the continents of North and South America got connected by a strip of land called the Isthmus of Panama. It formed because the tectonic plates shifted again. Some major volcanic activity between 25 million years ago also contributed to the process. Animals started to move between North and South America, and this long process went down in history as the Great American Interchange. During the Ice Age, huge glaciers in the north grew and shrank over tens of thousands of years. When the glaciers were at their biggest, they held so much water that the sea levels dropped, and forests probably turned into wide grassy plains. So animals had the perfect conditions to cross over. Giant ground sloths were among the animals that went up north from South America, all the way to Alaska. One special kind even roamed the chilly tundras alongside woolly mammoths and caribou. Lots of North American predators decided to explore the South. There were cats like cougars, jaguars, and saber-toothed tigers with their giant teeth. Wolves, foxes, otters, raccoons, and bears also joined the migration. The short-faced bear could stand up to 13 feet tall and weigh as much as a small car. South America also had some funny-looking animals called sanus, or South American native ungulates. These were hoofed mammals that evolved into all kinds of weird shapes, while South America was isolated. Big animals from North America, for example, relatives of elephants with strange tusks, came to the south and became some of the largest creatures around. The ancestors of today's llamas settled in the Andes Mountains, and deer, tapirs, and peccaries thrived in the forests. Animals kept moving back and forth between the continents for thousands of years. But as the Ice Age ended, many of the bigger animals, like the giant ground sloths, couldn't adapt and disappeared. It seems North American animals were better at adapting to their new homes. You can find armadillos, porcupines, and opossums from South America in North America. But many of South America's most famous animals like jaguars, llamas, and spectacled bears left North America long ago. Scientists think South America's animals, after being isolated for millions of years, had a harder time dealing with new challenges when their ecosystems changed. Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later. And these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduck, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. So get this, Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Date Line. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Date Line would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the date line from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Date Line look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the international date line that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international date line was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international date line didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is one day ahead and the other half is one day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international date line. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the date line. Suddenly, Kiribati was straddling the international date line. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the date line moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international date line, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international date line looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of Standard Time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the Daylight Savings Time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have 1. This means that the sun rises almost 90 minutes earlier in Dong in the far east than in Gujarmoti in the west. And why do they have only one time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So, if a country wants to stick with just one time zone to simplify processes and business operations within its border, then hey, why not?
You're down in one of those polar seas where the Brinicle, eerily called the Finger of Death, is born. It's a strange, almost otherworldly place, the deep ocean, where light barely reaches. Everything down there seems to have adapted to survive in darkness and intense cold. But even those truly hardy creatures aren't ready for what a Brinicle can do. When that briny, super-cooled water starts dripping down, a ghost story begins. The formation of these brinicles is a fascinating process, like an underwater science experiment happening in real time. We know that when seawater freezes, it doesn't freeze like freshwater. Because of all the salt in it, it has to push out impurities to form the pure ice that floats at the top. This means the salty water, or brine, ends up trapped in channels and pockets within the ice. When it sees the light of day for the first time, a brinicle resembles a pipe of ice reaching down from the underside of a layer of sea ice. At first, a brinicle is very fragile and its walls are thin. But the continuous flow of colder brine supports the growth of the brinicle. It also prevents it from melting. Otherwise, this process would be inevitable, caused by the brinicle's contact with less cold surrounding water. As the ice accumulates and the walls become thicker, the brinicle becomes more stable. Over time, the brine trapped inside gets squeezed out through tiny cracks, dripping down in this cold, heavy plume. Once that cold brine starts flowing downward, it begins freezing the seawater around it into a sheath of ice. That's why, instead of melting as it hits the water below, it forms this icy casing that protects it, helping it grow longer and stronger. The brinicle keeps moving forward inch by inch, and this crazy downward spiral is almost unstoppable. And when it touches down on the seafloor, that's when the trouble begins for anything living nearby. Imagine being one of those creatures on the seafloor, maybe a sea star or an unsuspecting urchin just trying to make it through the day. And all of a sudden, you see this icy tentacle nearing you. It isn't just some cold water coming down. It's basically a net of ice moving down and spreading out. There's no escape, no way to predict its coming, and no chance for survival. It's a slow-motion natural disaster in action. When a brinicle reaches the seafloor, it continues to accumulate ice while the surrounding water freezes over. The brine keeps traveling across the seafloor in a downslope direction. Once it reaches the lowest possible point, it stops and pools. But don't let the danger distract you from how beautiful brinicles are. Well, in their own creepy way. They look like something you'd see in a dream. Elegant, twisting ice tubes reaching down, perfectly symmetrical, and totally random. Filming a brinicle is no easy task because they're delicate when they first form. Just the motion from a nearby current or a sudden change in temperature can snap them off, ending the show before it really starts. So, scientists who managed to capture brinicles on film in 2011 actually got incredibly lucky. It was the first time the world got to see this icy finger descending and freezing everything it touched, and it changed our understanding of polar ecosystems. Brinicles can reach quite impressive sizes. Sometimes they can stretch for several feet. Their size depends on the conditions of the water and ice above. The slower the water movement and the colder the temperature, the bigger and stronger a brinicle can grow. But if the water's too deep or if there's too much movement in the current, the brinicle is likely to break apart. It needs just the right balance to survive long enough to touch down and freeze over the ocean floor. For creatures living on the seafloor, brinicles are like invisible booby traps, only instead of avoiding a net, they're avoiding an expanding ice cage. Starfish and sea urchins might not have big brains, but they have a basic survival instinct to crawl away from danger. Sadly, with brinicles, they're usually caught completely off guard. One second they're minding their own business, The next, an icy sheet is closing in around them, trapping them where they are and freezing them almost instantly. It's hard not to feel sympathy for these creatures, right? You watch footage of a brinacle in action and you see a starfish just stopping. One moment it's moving slowly along the sand, and then it's frozen in place, totally helpless. It's like watching a train wreck in slow-mo. Luckily, brinicles present danger only to smaller marine life forms like sea urchins and starfish. Bigger animals like seals or whales, or humans who happen to go diving in the ocean at the frigid poles, brinicles are totally harmless. At the same time, for scientists, this tough natural phenomenon offers a fascinating insight into how life adapts, or fails to adapt for that matter, in extreme environments. And it gets even better. A brinacle might just be the perfect setup for life to begin. Researchers are now looking at these super salty ice tubes as not just fatal traps, but potentially as sources of life. This theory isn't just science fiction, it's rooted in actual research. Here's how it goes. The brine channels in sea ice are full of tiny, confined spaces. Those are exactly the kind of places where chemicals can get trapped, concentrated, and start interacting in interesting ways. It's like setting up a mini-lab where the building blocks of life can come together and create something new. Scientists think this process of salt rejection in sea ice could have actually helped the first bits of life appear. Some researchers even think that this process might be happening right now on icy moons like Europa, Ganymede, or Enceladus, where there might have been frozen seas beneath thick ice layers. Just imagine it. Brinicles forming in other worlds of our solar system, laying down the foundations for extraterrestrial life, and all thanks to the same icy process that creates these fingers of death here on Earth. One way scientists describe brinicles is by comparing them to chemical gardens. Have you ever done one of those experiments where you mix metal salts into a solution and watch them produce plant-like structures? Well, you can observe a similar chemical process when a brinacle is in action. In the cold, saline-rich brine of a brinacle, certain reactions could kick off to create amino acids or other building blocks of life. It's wild to think that something so dangerous could have also helped shape our world, or could be creating other forms of life elsewhere. In both cases, whether on Earth or another planet, these icy chemical reactions might be the first step toward the formation of simple life forms. It's a kind of alchemy, where ice and salt water mix to create something more than the sum of their parts. This is one reason why scientists are so eager to study brinicles. Each one could hold a tiny clue about how life begins, survives, or fails under extreme conditions. Something as mesmerizing and weird, but at the same time simple as brinicles, hints at bigger questions. How did life start on Earth? What are the conditions needed for life to survive in extreme environments? Could icy structures like these exist in other parts of our solar system or beyond, creating similar conditions that might one day give rise to alien life? As much as they look like a silent threat reaching out from the ice, brinicles are also reminders of how beautifully complex and interconnected our world is. They may seem like simple fingers of ice, but they hold secrets that touch on everything from ecology to chemistry, to the origins of life itself. So next time you hear about the ocean, remember that deep below in the darkest, coldest waters, something incredible and a little bit terrifying is happening right at this moment. The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aqua fence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
You type Tonga Cliff Mystery into Google and this pops up. A rock. Yep, just a rock. At least at first glance. But it gets weird once you realize this is actually a 2-story tall boulder perched on top of a 120-foot high cliff in Tonga. And it's chilling there, at a whopping 128 feet above sea level. So, how the heck did this rock get there? First, a proper introduction. This is Makalahi, which means big rock in Tongan. This name hits the nail on the head because this baby stands at about 22 feet tall. That's taller than a giraffe standing on its tiptoes. And it weighs over 1,300 tons. And that's like stacking nearly 325 elephants on a giant scale. With those massive measurements, it makes total sense that the locals call it Makalahi. But from now on, we can also think of it as the giant tsunami rock. And to understand why, I've got to tell you the story of Makalahi in Tonga. In 2024, researchers from the University of Queensland's School of the Environment were exploring the southern side of Tongatapu Island. One day, they were chatting with a group of local farmers who mentioned a strange and massive rock sitting up on a cliff. And they were honestly pretty surprised. After all, it didn't make any sense for such a huge boulder to be located that far inland, especially since it's sitting about 656 feet away from the edge of the cliff. On top of that, it was covered in vegetation and surrounded by overgrowth, which suggests it's been sitting there for a long time. That's when they started asking themselves the big question: where did this rock even come from? So to figure it out, the team created a 3-dimensional model of the boulder and headed to the coast. After some careful research, they finally found the spot where the boulder could have originated. Turns out it broke off from a cliff more than 90 feet above sea level. Alright, so they found the source, but let's take a moment to recap what we know so far. The rock originally came from a spot about 98 feet above sea level, and now it's sitting at 128 feet above sea level. That's a pretty big jump. Sure, it's not like climbing Mount Everest or anything, but come on, it's a rock. It didn't just grab some gear and climb up there by itself. That brings us back to the big question. How did this massive boulder get up there? Well, it was probably moved by a tsunami. Yep, this rock could actually be solid ancient evidence of a tsunami. You see, we're talking about Tonga, an island country in Polynesia, part of Oceania. It's made up of nearly 170 islands with about 36 of them inhabited. The country is divided into 3 main island groups, the Vava'u, Ha'api, and Tonga Tapu archipelagos. The entire region sits right at the junction of 2 major tectonic plates, the Indo-Australian plate to the west and the Pacific plate to the east. It's part of the Pacific Ring of Fire, that giant horseshoe-shaped zone that wraps around the ocean basin. And if there's one thing we know about the Ring of Fire is that it's packed with intense geological activity. With lots of earthquakes and volcanic eruptions happening all the time, and those events can absolutely trigger catastrophic tsunamis. Tonga is no exception. According to Dr. Annie Lau, a coastal geomorphologist who took part in the study, Tonga has a long history of tsunamis for exactly that reason. Take the tsunami that hit the country at the beginning of 2022, for example. That catastrophic event produced waves as high as 66 feet, with water pushing nearly 0.62 miles inland. It was so powerful that, tragically, it claimed the lives of at least 6 people, and it was actually triggered by a volcanic eruption. So yeah, tsunamis are pretty common in Tonga, thanks to all that magma and tectonic activity constantly happening beneath the surface. And a massive, powerful wave is likely what carried Makalahi up onto the cliff. According to the study, this event may have happened around 7,000 years ago. That's even older than the first human settlement in Tonga, which is believed to have occurred roughly 3,000 years ago. Interestingly, that estimated timeline lines up with evidence of a massive tsunami that hit New Zealand's North Island, around 1,300 miles southwest of Tonga. The researchers had a theory. Now all they had to do was run the numbers to see if it was actually possible. So they measured the boulder's size and weight, then used that data to model how big a wave would have to be to push such a massive rock that far inland. Their findings suggest the boulder may have originally sat near the edge of a cliff, but was shoved inland by a tsunami. The wave lasted about 90 seconds and reached up to 164 feet in height. That's almost as tall as Niagara Falls. Just to give you a perspective, that's significantly larger than the waves recorded during the Indian Ocean tsunami in 2004 or the Tohoku tsunami in 2011. Now, here's the thing. These tsunamis were triggered by earthquakes, and waves caused by earthquakes usually top out at just a few tens of feet. So, in Makalahi's case, it probably wasn't an earthquake that did the job. Instead, it's possible the wave came from a landslide tsunami. This theory suggests that the earthquake not only generated a tsunami that flooded the island, but it probably also triggered a massive landslide. When a huge chunk of material suddenly slides into the ocean or something shifts quickly underwater, it can create a landslide-triggered tsunami, and that landslide, in turn, may have produced a second tsunami. One powerful enough to carry Makalahi and drop it where it still sits today. Now, while science may have found a likely explanation for how the rock got to such a strange location, many locals will probably continue to pass down the traditional stories tied to rocks like this one. According to Polynesian mythology, coastal boulders like Makalahi were placed by the legendary hero Maui. In some legends, Maui used a giant boulder and a magical rope made from the hair of the deity Hina to anchor the sun and slow it down. Another story is known as the Maui Throwing Stones. It refers to a group of 8 coral limestone boulders located in the village of Havelukilu on Tonga Tapu. The myth mentions that these massive stones were thrown to Havalukilu by Maui from the neighboring island of Eua. The story goes that Maui was annoyed by a rooster that woke him up every morning, so he picked up stones and hurled them at the bird. And that's how the rocks from Eua ended up in Tongatapu. Now here's the interesting part. The term white chicken in Tongawan also means foaming waves, so some believe this story may actually be a metaphor for a tsunami. Even though these myths don't mention Makalahi directly, they show how important rocks like these are to local people. Now, we can say that this archaeological evidence is not only important for culture, but also for science. The recent study gives us some fascinating theories about how the rock ended up so high up and so far inland. But researchers still need to find what's called a landslide scar to prove their point and fully solve the Tonga Cliff mystery. Follow-up research is crucial because it will help us to uncover what triggers these kinds of events and how often that might happen. And who knows? One day we might come across new cases of giant rocks moved by giant tsunamis, each one carrying its own story from the deep.
Scientists just uncovered what's basically Earth's own version of a dinosaur fossil hidden deep under the ocean near Easter Island. It's like finding a time capsule from 200 million years ago, revealing secrets of our planet's very ancient history. Earth's surface is made up of giant pieces, like puzzle pieces, called tectonic plates. These plates are slowly moving around all the time. Under these plates, there is a super hot layer called the mantle, and this layer is what helps the plates move. In September 2024, a team of geologists finally published the groundbreaking discovery that mentioned this ancient megastructure. This old piece of ocean floor might be connected to why the ocean floor is spreading apart faster in some places than in others. To figure this out, scientists use sound waves, known as sonars, to create a sort of map of what's happening deep underground. What they found was weird. There's a blob of stuff under the Nazca Plate, a plate near South America, that's moving much slower than it should be. Now, normally, when plates move, some of the material sinks into the Earth like a conveyor belt. But in this case, it's going slower than expected, like it's getting stuck on something. That something could be an ancient part of the ocean floor that got pushed down into the Earth about 250 million years ago. This discovery is like finding a fossil deep inside the Earth that shows us what things were like a really long time ago. When the ocean floor spreads apart, it's because two tectonic plates are moving away from each other. In the middle of the ocean, there's a long crack or ridge when this happens, kind of like a seam in the Earth. As the plates pull apart, hot melted rock called magma from deep inside the Earth bubbles up through this crack. When the magma hits the cold ocean water, it cools down and hardens, creating a new crust. This process keeps pushing the plates further apart. This process is also known as the Earth's mantle's recycling system. It's like the Earth keeps generating its own mantle constantly. On the surface, this process can cause earthquakes, underwater volcanic eruptions, and the formation of new land, sometimes even creating volcanic islands over millions of years. The cracks where this spreading happens are called ocean ridges, and one of the most famous ridges is the one we're talking about now, the East Pacific Rise. It's famous because it's spreading faster than most ones. This new discovery helps to explain why this may be so. You see, this huge megastructure sort of serves as a time capsule. Since the Earth's mantle is constantly changing and being created, finding a fossilized version of it is making scientists go bananas. It shows us what Earth looked like millions of years ago, back when the continents were in different places and our buddies dinosaurs roamed the planet. This ancient chunk of ocean floor also helps us understand how tectonic plates have moved through history. Although we usually hear and talk about Pangaea, the first supercontinent to exist on Earth was actually called Valbara. The shifting and moving of these tectonic plates are actually what gave rise to the continents we know and live in today. This huge fossil can also help to improve our knowledge of the so-called Earth's mantle's recycling system. By learning how this huge piece of crust got stuck and slowed down, scientists can better predict things like volcanic eruptions and earthquakes. Plus, it might even help us understand how other planets, like Mars or Venus, work beneath their surfaces. Well, I'd say science has a lot on its plate now. Pun intended. Other surreal stuff is constantly being found at the bottom of the oceans, seas, and lakes. Like this underwater Stonehenge. Scientists discovered a mysterious pile of cairns that stretched for miles under the shimmering waters of Lake Constance at the edge of Switzerland, Germany, and Austria. Archaeologists began to discover this back in 2015, and they haven't been able to understand what the site was actually used for. What they know until now is that there is a 12-mile line of 170 man-made stone cairns submerged under Lake Constance. Scientists say this was most likely the work of several villages, and that the cairn site was probably used for some collective purpose. The formations are huge, some of them are several dozen feet wide, and they can build up to 6 feet. The site probably dates back to 5,500 years ago. Now, it's no coincidence that scientists are calling this site the underwater Stonehenge, though. Both sites are believed to have been built around the same period of time. You see, Stonehenge dates back to around 3100 BCE. And also, both sites carry the distinct characteristics of stone monuments built in a circular format. Let's say they're like cousins. Meanwhile, in 2007, archaeologists found what looks like another mini version of Stonehenge underneath Lake Michigan. It's about 40 feet underwater, and this circle of stones is believed to have been created by indigenous people. They would have built it during the last ice age, when the lake wasn't even filled with water. The rocks are about 4 feet tall, and one of them might even have a carving of a mastodon, which was a huge elephant-like animal that lived more than 10,000 years ago before going extinct. If the carving is real, it could help scientists figure out just how old this site really is. What makes this even more mysterious is that nobody knows why the rocks were arranged in this way. But since a similar stone structure was found on Beaver Island nearby, experts think it's no accident. They were definitely placed there on purpose. The stones form 2 rings. The outer one is about 40 feet wide, and the inner one is about 20 feet wide. All the rocks are made from local granite, and they've been down there for around 9,000 years, which makes this one of the oldest structures in North America. To give you an idea of how ancient that is, these stones were set up long before the famous Stonehenge in England, which wouldn't be built for another 4,000 years. Now, all the way over in Japan, this mysterious structure was unearthed. At first, it looks like an underwater Machu Picchu. The site is filled with a huge pyramid-shaped structure, arches, staircases. It's something that could have easily been a palace or a castle. Behold, the Yonaguni Monument. It also goes by the name of Japan's Atlantis. The entire monument is about the size of 5 football fields and the height of a 5-story building. Its most surprising structure is its expansive terraces that host large crowd gatherings. Explorers and scientists believe that Yonaguni dates back to 10,000 years ago. But whether it is a human-made structure or a natural formation is still under debate. For Japan's top marine geologist, Yonaguni is the heritage of a lost civilization. This guy has dived into exploring the ruins over 100 times over the past 10 years. According to him, there are clear signs of human activity down there. The triangle pool, located on the monument's surface, is a triangle-shaped concave that is a historical symbol of water fountains in the region. There's also a giant turtle carved on the eastern side of the structure, which has an important cultural meaning. Several pieces of stone tools have been recovered from the site. Their estimated age dates back to 10,000 years ago. However, not all scientists are convinced of this explanation. For many, Yonaguni is the result of thousands of years of erosion. The fact that the monument is composed of one massive rock leads them to believe it is not human-made. The defined edges and flat surfaces resemble a natural formation occurrence in Northern Ireland known as Giant's Causeway. A series of interlocking basalt columns look like the ruins of a palace, but they were the result of volcanic activity in the region.
Be careful, one. Save yourself. We're drowning.
Quick, check this out. Over 5,000 ships have been lost near this coastline. Pirate galleons, Civil War ironclads, even modern boats. They've all gone whoosh under the waves. This is a story about the famous graveyard of the Atlantic. For sailors, one of the most dangerous places on the planet. This place is called the Outer Banks, located off the coast of North Carolina. It consists of long, narrow islands that look like nature's speed bumps between the Atlantic Ocean and the mainland. From the air, they stretch out like lazy strips of tan ribbon floating on blue water. You'd never guess anything sinister happened here. It just looks like miles and miles of soft beaches, ready for bonfires and beach parties. Except these islands are, for lack of better words, restless. Geologists sometimes call them barrier islands, but the word barrier makes them sound solid and dependable. Truth is, they're more like runaway sand piles, always rearranging themselves whenever the sea decides to push and pull. Even Google Maps can barely keep up. Islands shift, they slide, they crack in half and come back together again. A storm doesn't just mess up your beach castle, it might literally erase the entire beach. In 1846, a hurricane punched straight through one of these islands and created an entirely new inlet that's been shifting ever since. One other cool example is from 2003, when Hurricane Isabel remodeled the landscape with a brand new 1,700-foot wide inlet. It cut a section of the island completely. People were stuck on the wrong side. The only way in or out was by boat or airlift because the road was completely underwater. Yes, an entire highway was washed off and submerged. There had to be at least one local who was like, "Hey, cool! I always wanted to live on an island inside another island." More recently, in 2017, a brand new island nicknamed Shelly Island suddenly appeared off Cape Point. People were walking on it, taking selfies, posting TikToks. Less than a year later, gone. Vanished back into the waves like some kind of magic trick. That's what makes this place so unpredictable. It's like the land is on loan from the sea, and the sea always wants it back. But why does this happen? Let's say you build a sandcastle right where the waves keep hitting. Not up on the dry sand, but right where the water's coming in and out. Every time you shape it, the water swooshes in and steals a little piece of it. Now imagine that instead of one castle, you're trying to build a whole island like that. That's basically what the Outer Banks do every single day. That's because these islands are made of sand, not rock. Just soft, annoying, squishy sand. And the ocean is constantly poking at them, stealing a bit here, piling up more over there, and rearranging everything like it's playing a giant game of beach Tetris. Now, add some powerful forces underneath the water. Here, the Gulf sends up a blast of warm water. The Arctic sends down icy waves, and they collide into a swirling milkshake that scrambles sandbars all over the place. This is what makes it so dangerous for ships. Imagine wearing a pirate hat and navigating your Black Pearl through something so unpredictable. Or even a modern cargo ship. The water's shallow, but it doesn't look shallow. The sandbars are underwater, but they move around. The currents are pulling your ship in every direction except the one you want. And even if you are a master helmsman, you still have to deal with fog so thick you can't see your own mast, followed by storms that smack ships around like toys. As you can see, it's not one single trap, it's the whole ocean acting like it's out to get you. And for thousands of unlucky ships, it did. This stretch of water has always been a magnet for pirates, scavengers, and anyone with an eye for opportunity. You probably heard about Blackbeard, the legendary pirate who plagued the American coastline in the early 1700s. His flagship, the Queen Anne's Revenge, sank near Beaufort Inlet in 1718. Stories say Blackbeard even blockaded the entire port of Charleston before his ship finally went down. And yep, it's still there. Divers found the wreck in 1996, and they're still pulling up cannons, gold dust, medical tools, and all kinds of 18th century pirate loot. Over the years, locals made a living salvaging whatever the ocean tossed onto their shores: timber, tools, cargo. If it washed up, it got used. The now abandoned village of Wash Woods, located near the Virginia border, was famously constructed by survivors of a shipwreck. They used cypress planks from a ship that had washed ashore during a storm in 1889 to build the village along the Virginia beach. They built homes, a church, and even a school out of wreckwood. Nice way of recycling. And then there's Nag's Head, which sounds like the name of a pirate bar, but actually comes with one of the coolest legends on the coast. According to local folklore, centuries ago, wreckers in the area came up with a sneaky trick. They'd tie lanterns to the necks of old horses, or nags, and walk them along the dunes at night. From far out at sea, that bobbing light looked like another ship sailing safely near the shore. Captains would follow it thinking they were in safe water, only to slam straight into a hidden sandbar. Now, is that legend true? Probably not. Historians haven't found any solid evidence that it ever happened. However, when the ocean is sinking ships full of goodies near your shores, becoming a shipwreck scavenger starts to sound like a pretty solid career move. But even with modern technology, ships are still getting wrecked. In 2012, the tall ship Bounty sank off the coast during Hurricane Sandy. It was a modern tragedy with a very old pattern. A ship meets a storm, and the storm wins. The boat was actually famous. It was a Hollywood-built replica of the 18th century Royal Navy ship with the same name, created for the movie Mutiny on the Bounty. The original met its fate in 1789, when it was burned after the infamous mutiny. Then in 2020, the Ocean Pursuit, a commercial fishing vessel, ran aground near Bodie Island. And it's still there, slowly being swallowed by sand and surf. There are many similar examples. Whether you're a pirate, a U-boat commander, or just trying to catch some tuna, the graveyard of the Atlantic doesn't care. If you sail around here, you might just become part of the collection. And get this, we haven't even found everything yet. A lot of shipwrecks in the Outer Banks are still buried under sand dunes or lurking underwater. Some of them only show up when storms change things around, kind of like the ocean lifting a little peek of its curtain. Archaeologists keep finding new wrecks, even decades or centuries after those ships went missing. Who knows what else is hiding down there? It could be a real pirate treasure. Maybe some cannons or a whole ship lost to time. Not to mention that it's not just about money or gold coins. Every wreck is a time capsule, sealing away stories of people, technology, and history. To divers and archaeologists, that's a kind of treasure you can't put a price on. But if it's so dangerous, why do they still use these ocean routes? Even with the risks, ships still pass near the Outer Banks, since it's right in the way of a major shipping route. The Atlantic coast of the US is super busy, and the Outer Banks is positioned between northern ports and southern ports. If you're transporting goods, it's tough to find a shortcut without wasting time and fuel. Plus, modern technology does help. I guess the moral of the story is, get a better ship with GPS and sonars. The graveyard of the Atlantic is still open for business. Ships keep sailing through, storms keep rolling in. And the sea?
If you take 4 Burj Khalifas and stack them on top of each other, they'll be just slightly taller than the underwater mountain that oceanographers recently discovered. This giant sits in the Pacific Ocean off the coast of Chile. It's part of an underwater mountain range that has some pretty wild things, like a coral garden almost as large as 3 standard tennis courts for doubles, and some marine species we've never seen before. A group of scientists from the Schmidt Ocean Institute explored the mountain on a special research vessel. They were on a mission that lasted for 28 days. During this time, They used a high-tech sonar system attached to the bottom of the ship. They send sound waves down to the bottom of the ocean. When these sound waves hit the seafloor, they bounce back up to the ship. By measuring how long it takes for the sound waves to travel down and come back up, the scientists can figure out the shape and features of the seafloor, like hills, valleys, and mountains. Right now, we only have detailed maps for about 26% of the seafloor, just a little more than 1/4. But the seafloor covers about 71% of the whole Earth's surface. The team of scientists used a special underwater robot to study one of the mountain's ridges and found a whole bunch of creatures. One of them was an octopus looking like a little ghost. It was all white, and the scientists nicknamed it the Casper octopus because it reminded them of the friendly ghost Casper. No one had ever seen this kind of octopus in the southern Pacific Ocean before, so it doesn't even have a real scientific name yet. The team also found another strange animal, an underwater creature looking like spaghetti. These guys are very rare. The scientists also recorded the first official footage of a special, rare type of squid. Before this, they only knew about it from a few lifeless specimens they had found. Over 3 expeditions to the Nazca Ridge, the scientists managed to explore and map 25 underwater mountains. They also cataloged 150 species they had never seen before, and there are 20 more potentially new species just from the latest expedition. They're going to share all these discoveries with a group called the Ocean Census. Their goal is to identify about 100,000 new species in the next 10 years. They hope to understand the deep ocean better and find ways to protect all the amazing life down there in this way. There are more than 14,500 identified seamounts, or underwater mountains, in the world's oceans. But satellite data and data from survey ships shows us there could be over 100,000 seamounts. Most of them are leftovers of extinct volcanoes. You can mostly find them in places where Earth's giant puzzle pieces, the tectonic plates, meet and move apart. When it happens, hot magma from inside the Earth rises up to fill the gaps. When the magma cools down, it creates new crust and sometimes builds up into seamounts, or volcanoes. Seamounts are also formed near subduction zones. These are areas where 2 plates are pushing into each other. When one plate is forced down under another, it dives deep into the Earth's hot inside. The crust that goes down melts and turns into magma again. This hot magma rises back towards the surface because it's lighter than the surrounding rock. When it reaches the seafloor, it erupts, and volcanoes and seamounts are born. Seamounts are normally shaped like cones, but some leave craters, ridges, or flat tops, as if someone cut off the tip of a cone. The general requirement for a seamount to get that title is to be at least 3,300 feet tall from the bottom of the ocean. That's about 3 times as tall as the Eiffel Tower. Mauna Kea definitely deserves to be called a seamount, and also the highest mountain on Earth. Yep, Everest has nothing on it if you compare their heights from the bottom to the top. Mount Everest is very heavy because it sits on top of a thick, dense continental crust. This crust already has a lot of weight pushing down on it from the mountain above, so it can't support much more height. Mauna Kea is on a thinner oceanic crust, which has less rock above it and more water. The oceanic crust doesn't have as much weight pushing down on it, so it can hold up a taller mountain like Mauna Kea. This seamount beauty is about 1 million years old. It was in its active stage of life hundreds of thousands of years ago. The last time it erupted was 6,000 to 4,000 years ago, and it's sleeping now, but could still wake up at some point in the distant future. Even though it's in Hawaii, Mauna Kea has an alpine climate. The temperatures can change a lot from day to night, but they don't change very much from season to season. Snow at an altitude of 11,000 feet and higher can fall here at any time of year, but it happens the most often from October to April. It didn't stop the ancient Hawaiians, who lived in caves at these heights and quarried basalt for cutting tools. The top of Mauna Kea is one of the best places in the world for looking at stars and planets because the conditions up there are just perfect for it. First, the summit is in a very dry area, which is important for astronomers. When scientists study light from stars and galaxies, they need clear air without moisture, like water droplets in the air. This dry air helps them see better when they look through telescopes. Second, the summit is higher than what is called the inversion layer. This means that most clouds are below the top of the mountain, and astronomers can see the sky clearly without clouds blocking their view. The air at the top of Mauna Kea is very stable, and it helps see stars and planets very clearly. Finally, the mountain is far away from bright city lights, which makes the night sky really dark. There's an interesting group of seamounts not so far away from Mauna Kea, north of the main Hawaiian Islands. You can meet Mendelssohn, Gershwin, Beethoven, Verdi, and other famous composers here. And yep, all of them are seamounts. They were all discovered in the middle of the 20th century. It was the time when modern oceanography was just beginning, and there was a lot of research work in the Pacific Ocean. Hundreds, then thousands of seamounts were mapped, and whoever had to name them probably ran out of names or decided to honor the talented and famous musicians. There are also mathematician and mapmaker seamounts. There are about 25 members of the musician seamounts group, and they were formed back in the Cretaceous period, during the time when dinosaurs roamed the Earth. They built up over millions of years. Some of them made it above the ocean's surface and became islands, and others are still hiding underwater. Studying seamounts helps scientists understand how the Earth was shaped by volcanic eruptions and the movement of tectonic plates. They often attract mining companies that want to collect valuable minerals that gather around them, thanks to hydrothermal activity. Seamounts are also home to many different kinds of marine life, so they're important fishing areas. You can find more than 80 types of fish that people catch for food around these underwater mountains. Researchers are especially interested in how seamounts interact with ocean currents. These interactions may help create special places called hotspots, where new species can form and where there is lots of biodiversity. Scientists also think that seamounts could serve as safe havens or stepping stones for sea creatures in large areas of the ocean that are otherwise empty and barren. They want to know how the populations of animals living on seamounts change when the ocean's currents shift, and if the ecosystems that are disturbed by human activities can bounce back.
Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynya isn't near the coast. where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data, satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen and sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs. You can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse. In the winter of 2019, the American Midwest and Northeast turned into a real-life disaster movie. I'm talking about that time when temperatures dropped to negative 63 degrees Fahrenheit. There were massive flight cancellations and power outages, dozens of injured people, and shut down schools and offices. Simply going outside became highly risky. And if you're looking for someone to blame for all this, I've got 2 words for you: polar vortex. That's not some scary storm, but a huge mass of cold air that's normally spinning counterclockwise around the poles. When it's summer up in the northern hemisphere, the vortex stays further north, and in the winter, it heads south a bit. The term polar vortex has been around since the late 1940s. It shows up every winter and calls it quits in the spring. But for about the last 20 years, this polar vortex has been acting weird in the middle of winter. It looks like it either splits or becomes displaced once every other year. At the bottom of this vortex is what they call the polar front, or the polar jet stream. This jet stream moves from west to east, which is why places like the northeastern part of North America get hammered by that chilly polar vortex weather. Ooh. These jet streams zip along because of differences in temperature and the Earth's spin. When there's a big gap in temperatures, the winds really pick up speed. In spots like the equator, where the sun's rays are more intense, the air heats up and starts to rise. And as it goes up, it leaves behind a sort of empty space, taking in air from all around, kind of like a huge vacuum cleaner. But over at the poles, where it's way chillier, the air shrinks and sinks, forming areas of high pressure. It's like a bunch of air molecules trying to spread out, like a group of school kids on a big field. So you've got these two forces at play: warm air rising and cold air sinking. Air wants to zoom from the poles down to the equator with this setup. The jet streams tend to hang out where airplanes fly, about 30,000 feet in the air. Pilots often use them to zoom across the sky faster and save some fuel. But these jet streams aren't always the good guys, as they can bring all sorts of weather changes, like cold snaps and heat waves. When the polar jet stream is strong and cruising at about the same level as the vortex, it kind of locks in that cold Arctic air within the Arctic Circle. Every now and then, the jet stream takes a chill pill and starts moving around the planet in a wavy pattern called Arctic oscillations. This creates peaks and troughs that allow warmer air from down south to head north, and the chilly Arctic air to take a trip south. In the northern hemisphere, there are two polar vortexes, one in the lower atmosphere, known as the troposphere, and another higher up in the stratosphere. The stratospheric vortex forms as cold, dense air sinks and twirls near the North Pole. The mightier the vortex, the quicker it spins, keeping cold air locked over the high latitudes. When someone or something messes with the polar vortex, it goes haywire. Picture a spinning top. Give the table a shake and it'll start wobbling. When the polar vortex loses strength, it can't corral the cold air anymore. So, blasts of icy Arctic air surge southward over North America. The polar vortex isn't a fixed object, but more like a living being. It gets stirred up by ripples on Earth's surface, triggered by stuff like air flowing over mountains or across land and sea, all warming up differently. If our planet were as smooth as glass, with oceans wrapping all around, the polar vortex would just chill out, never breaking up. But every time a wave smacks into it, it gives the vortex a push. Sometimes, one of these waves packs enough punch to shove the vortex off the pole or even spin it in reverse. And when that happens, the temperature in the polar stratosphere can skyrocket by a whopping 50 degrees in just a week. The Arctic's polar vortex started spinning in the opposite direction in March 2024 and got scientists worried. It's one of the 6 strongest flips since the 70s. This time around, it hasn't caused any chaos. Sometimes the waves of air affecting the vortex get strong enough to split it into 2 parts, kind of like how a cell divides. They're called daughter vortices, and they even add more chaos to the mix. When the vortex splits, one chunk usually heads over Siberia, while the other cruises over North America. Once that split goes down, the jet stream in the troposphere above the Atlantic decides to take a southern vacation. That jet stream usually acts like a bouncer, keeping the chilly Arctic air up near the pole. But when it heads south, that Arctic air gets a green light to crash the party in places like the East Coast, the Midwest, and even Western Europe. The storms that usually ride along with the jet stream follow along and head south too. They take their time to get organized and catch up with the new path of the jet. So, instead of hitting up Canada like they usually do, they swing by New York and Chicago for a change of scenery. Scientists still don't know why the polar vortex doesn't mess with the U.S. Pacific coast. It might have something to do with where the jet streams hang out in each basin. Over in the Atlantic, the jet stream kicks it at higher latitudes, while in the Pacific, it's chilling closer to the equator. It might also have to do with the landscape. In the Atlantic, the air has zipped over the Rocky Mountains, stirring up waves off tall peaks that mess with the jet stream. But in the Pacific, the jet stream is away from any big mountains that could cause trouble. The recent reversal of the polar vortex is unlikely to make the temperatures drop extremely, but scientists aren't sure what's going to happen to the polar jet stream in the future. They're concerned that the chilly polar air might make more trips down to the mid-latitudes and bring along more chilly spells in the long run. So it's better to be prepared. When the news tells you there's a huge winter storm coming and power outages are highly likely, fill your bathtub with water. If you have an electric water pump, it won't work and you'll run out of water soon. Gas stations also run on electricity, so fill your car tank before the storm hits to have some emergency gas. When the storm arrives and you're locked in, put on several layers of warm clothes, thermal wear, a warm shirt, a sweater, and insulated pants and woolen socks. Don't forget mittens so the heat doesn't escape through your hands. Hang dark blankets on your windows to draw in heat. Make sure your doors and windows are closed well, and put some towels under them to prevent drafts. Your basement is probably more insulated by the ground, so it could be a good place to spend the night. To warm up the cold winter bed in your home, fill a bottle with hot water and place it in your core region under the cover. The water will heat up your vital fluids traveling through your body, reaching all the extremities and warming you up in no time. You can also wrap your pajamas around the bottle before putting them on for an extra effect. When the power comes back on, check all your appliances and electronics before turning on the main power switch. They must be unplugged to avoid power surge damage. As you turn the water supply back on, keep the taps on the lowest level of your house closed to let the air out from the upper taps. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.